What is up, guys? It's TimeForDillon back at it again with another crypto video. What is up, guys? It's TimeForDillon back at it again with another electronics tutorial. Thank you guys for tuning in. You guys are awesome. In today's video, we're continuing back off with our Elegoo Uno R3 most complete starter kit. And of course, we're going to be covering lesson number 15, the Max 7219 LED dot matrix. So just like every video, I'm going to show you guys how to set this thing up just in case you need some extra help. And of course, we're going to take it one step further, like I always do. And I'm going to show you guys how to set this thing up to work with the analog joystick so that you're able to actually play fully functional the game of Snake. Pretty sick, right? As you can see, I can move this guy around. As I eat the little red dots, my snake grows by 1 dot length. And the goal is to just last as long as possible without touching the edge of the walls. So pretty cool little system we got here. Of course, we're going to walk you through the exact tutorial setup so that you guys can build this along with me. I'm going to walk you through the code, exactly how to set this sucker up. Not too much code, about 200 lines of code, maybe a little bit less, but I'm going to show you exactly everything you need to know to get this sucker done. So make sure you guys stay tuned until the end. Of course, let's get started with the tutorial. What I'm going to do is unplug this entire setup and show you guys how to do it from scratch. So let's get started. So what you're going to need for this tutorial is, of course, the Elegoo Uno R3, the Max module, 5 female-to-male jumper wires, and of course you're also going to need the joystick. So I have the joystick, I have 5 female-to-male jumper wires on this guy. I just taped it to my breadboard because both of these modules use a 5-volt connection. So we're going to need to plug it into the breadboard. And then what I did was I jumped it over from the Elegoo, the ground and the 5-volt, onto the positive and negative rails of this breadboard. So I'll show you exactly how to do it. So basically what you're going to need is the breadboard, the components I just talked about, which are the joystick, 5 female-to-male jumper wires, the Max module, 5 female-to-male jumper wires with this, so 10 in total. And then we're going to need the Elegoo Uno R3 with 2 male-to-male jumper wires. So let's just read into this tutorial, see what we're going to do. So basically this module, it allows you to scroll text across the screen. Since these modules use the Max 7219 LED driver chip, we will also turn on and off the 64 LEDs of each module using only 3 pins, because 2 of them are ground and VCC, as you guys can see. So a little bit about this is basically it's serially interfaced. It operates on an 8x8 LED matrix. Pretty cool. Bunch of mumbo jumbo. You guys can read all about that. Basically, we're using 5-volt. These are the regular operating current, which is 320 milliamps. The max operating current is 2 whole amps. The wiring setup is very simple, just like all of these tutorials that we've been doing. They're pretty simple. Just gets a little complex once we start introducing multiple modules, which we're going to see in today's video. But this is how we're going to wire it. Very simple. So we're just going to do VCC and ground into 5-volt and ground, which we're going to actually do this with the jumper cables. So I'm going to show you exactly how to do this. And then we got to do DIN, CSS, and CLK in that order, if you guys can see, into 12, 11, and 10. So not very hard to plug this guy up. So let's go ahead and set this up. Switch my view over so you guys can see exactly how I'm going to do this. Like I said, I already have my joystick taped to my breadboard. So I just did like a flipper tape, you know, a little tape roll, put it underneath, and then I taped this side and this side to the bottom just for some extra stability. That way it doesn't move around when I'm using it. And then, of course, if you guys remember from the tutorial, we have, if you guys can see, we have a ground and a 5-volt, which I plugged into the appropriate rails here. So the plus rail is going to be our 5-volt. The minus one is going to be our ground. So I have those set up. And then these 3 cables, we have VRX, VRY, and SW. So VRX goes into analog 0, VRY goes into analog 1, and SW goes into pin number 2. we can go ahead and set these up. Pretty simple. So VRX goes into analog 0, which is right here, analog 0, boom. We have VRY, which goes into analog 1, and then this white cable, which is connected to SW, goes into pin number 2, boom. So we can set those up. And then this guy, so these two on the top, as you can see, are VCC and ground, so we're going to plug those into this breadboard. We're just going to wait until we plug these other pins in. And then we have DIN, CS, and CLK. And like I said, it's going to go 12, 11, and 10 in that order. So let's go ahead and do that. 12, 11, and 10. 12, 11, and 10 in that order. And then we'll go ahead and plug in the VCC and the ground. So into the same rail that we have this other one plugged into. And then now all we have to do is just jump over these cables. We have our ground and our VCC. Plug it in here. Boom and boom. And let's restart this. And it's already working. So this is the code that I wrote for. This is the code that I wrote for the snake game. But what we're going to do right now is we're going to just stop using this, and we're going to pull up the code for this project just so we can get an idea of how it actually works. But what we're going to do now is we are going to open up the file that is associated with lesson 15. So just go to File, Open, navigate to wherever your folder happens to be. Mine's on the desktop. English, lesson number 15. Here it is. Boom, and this is it right here. So I'm just going to minimize that other one because we are going to come back to that while I explain exactly how you need to set this thing up. Go ahead and press upload. Actually, what we need to do is we need to include the library. So go to include library, add zip library, and then same thing, same exact spot we just went for the sketch. Boom, lesson 15, LED control. You want to override the existing library. I've already installed it, obviously. You guys will need to install this. You won't get this error if you have not installed it already. Just go ahead and upload that, and we should be ready to rumble. So let's go ahead and upload the code. Now this always, I don't know why this tends to happen when I try to run code when I'm using this module. It seems to get an error. So what I found is you just plug it back in really quick and click upload. And then it seems to work. Arduino. Boom. And then it does a little light show for you. Pretty cool stuff. Taking a look at the code, though, we can see that the way that this is set up, see, I messed up and I saved these here. These are not for this project. Those are for the analog joystick, so you can ignore that. And then down here, I also have this. This was put in here just to get it to work. And if you guys recognize that, it's literally the same exact sketch code from the analog joystick example. And that's pretty much how I figure out how to do this, guys. I just get some of the code, I move it around, get it to work. And yeah, eventually you will be able to figure this out on your own without any help, which is a lot of fun. But anyway, how does this work? We're just including the library, instantiating the object, we're setting everything up, and then what are we doing? Write Arduino matrix. So this is how we write the Arduino. This is a function. Then we have rows. That's the second part of this little guy that gets set up, where we see the double dots going across the screen. Columns, same thing, but just columns. Single is just single lights, like what we are seeing here. Single lights filling up the whole matrix. So it just goes through all of these, as you can see in the loop. First thing we do is we write Arduino, then we go row by row, then we go column by column, then we go single dot by single dot. So pretty cool how we set this up. But of course, I know you guys are here to learn how to write the game Snake. So what I'm going to do is pull up my code and explain it to you guys. And if you're interested in copying my code, I'll go ahead and put it down below in the description, because I know you guys don't want to sit through an hour-long video, so I will spare you. But essentially, I'll explain how I set this up. Right? We have our library just like we had in the last thing. We have our pins, which are the same pins that we all used in the last lesson that we did 2 lessons ago, which was the analog joystick. It's the same exact setup, right? We have these pins here, and then when we move down, you'll see that literally I'm using the exact same thing to figure out how this direction is being moved on the pins. And to be honest, we really don't even need this pin because we didn't even use it. So we have the same exact setup here as we did in the example sketch. So we have the instantiation of the object with the same pins and everything. We set the matrix width and height, same exact thing because it's an 8x8 matrix. Now we're setting up some of the game features. So the first thing we need to do is we need to determine the length of the snake. So we're saying that the max length is 32. So basically, if the snake gets to 32, you win the game. As you can see, when you start the game, right? Let's deploy this code, and you can see. All right, when we start this game, it starts with 1. Right, and it grows by 1 each time. So think about it. If it's 32 snake pieces long, that's a pretty long snake. That's already 4 times the width or height of our matrix. So it's going to be big. It's going to be kind of difficult to play the game at that point. So that's why that's a pretty good number. Just, you know, you're going to have to be snake slithering around. It's going to be really hard. So I don't think anyone can really get there. And if you do, congrats. So we're setting the, so then we're going to set up 2 arrays for the snake's X and the snake's Y. And the reason why is because when you move the snake, right, if we watch the game, look, I can make the snake go in L formations. So that's why we need to keep track of X and Y in this situation. And then what we need to do is we need to set the length of the snake. This is with the length that the snake starts at. And then what we are doing is we are setting up food's position. So where in the matrix do we want it? X and Y, right? The enumeration, direction, up, down, left, right. This is how we're going to figure out how to move the snake. And then direction. Current direction equals right. And that's because technically the matrix is upside down. So I have the X and Y and technically the matrix is upside down, so I have it inverted, the direction. And that's because I want it facing, right? If you see it, I want it facing this way because the wires go that way, right? I mean, you could flip it upside down and then make it the correct way, but then how's it going to sit there? So that doesn't really matter. So then some of the variables we need for the game, of course, we need a game over variable, which is a Boolean value, which is true or false. We set it equal to false as we start the game. And that is because we want the game playing. We don't want the game over to be true. We only want it to be true when our snake hits the wall. And then we have unsigned long, which is the last move time, and of course the move interval. This is how fast things are moving. So then we're going to set up the game, right? This stuff right here is literally copied from the matrix sketch. So just copy it and paste it. This stuff is just methods being called for our instantiation of our matrix object. And then, of course, we have the snake and the food being set up. So snake X and snake Y, we're setting the initial position of the snake to 3, 3. And that's why when you look at this, you can see it's starting right there, which is really 4, 4, but because in computer science everything is 0-based, it's 3, 3, which is the 4th light in X and Y position. 0, 0 being this position up here. So that's how that works. And then what are we doing? We are calling a function place food. So what does place food do? Place food, this is all it does. Food X, food Y, which are the variables that we set up here. Where are they? Food X, food Y, bump, which is the food position. We are setting them equal to random, matrix width and matrix height. So these variables, matrix width and matrix height, are the same ones that we set up here, 8 by 8. So it's picking a number between 0 and 8, 0 inclusive. 8 exclusive, so 0 and 7. Very cool. So then what are we doing, right? We have our loop, which is saying it's going to run this code if game over is false, right? Not game over, which means game over is false. Otherwise, if game over is true, which means the game is over, we're going to clear the display. We're going to clear the row, right? We're basically setting this right. As you can see, when it hits the wall, we're setting this right row to full display, which means game over, which is this right here. Well, game over. Then we delay 1 second and we reset the game. So what are we doing in this game, right? Well, we're reading the joystick input to update the direction, right? We have 2 axis variables, into x-axis and into y-axis. X-axis controls left and right, or the x-axis. How are we getting that information? We're reading from the analog joystick. This is literally the same method that we used last time when we were controlling the joystick. And we're reading it from the X pin, which is pin 0, which is pin 0 on this guy, analog pin 0. Right, so we're reading the data from there. If you guys remember from the last video where I showed you guys how to use this, basically this joystick is a potentiometer. So while it's sitting idly, the X and the Y values are 5, 12. And that's because when you move it all the way to the left, it goes to 0. All the way to the right goes to 1024. Or really it's 1023. There's 1024 values. Same thing with Y. Up is 0. Down is 1023. So all we're doing is we're reading those values into these variables, and then update direction is a function right here that I'll show you, which puts these values into this. So basically, how does this work? Update direction. We're taking in these 2 values, which are values between 0, 1023 in the X direction, and same thing in the Y direction, 0 to 1023. And then we're putting them through this if statement, which is going to control which way the thing is going, right? And basically, right, if you think about it, the x-axis, if we move it all the way to the left, that's setting the x-axis value to 0 or close to 0. So we're setting like a little buffer, because while it's sitting idly, it's at about 512. So if we move it just a little, we don't want it to pick up the change of direction, because then it's going to be way too sensitive. It's like 10 sensitivity on your joystick. So we set a little buffer of 200. So basically, once it's really all the way to the left, or 300, then we're going to change the direction to right. If it's greater than 700, right, we move it to the... And remember what I said, we have it inverted because it's upside down. So if we press it to the right, the x-axis value will go up to 1023, which is greater than 700, so then it will update the direction to the left. We had to change this because it's upside down. So also with the y-axis, if it's less than 300, it goes up. If it's greater than 700, it goes down. Same thing. Basically, it's picking up the direction we're pointing the joystick. Okay, let's keep looking at our loop. So we've now have movement, right? So now we need to move the snake at regular intervals. So millis, if you guys remember this function, essentially what it does is it reads the time from the start of the Uno R3. Once the Uno R3 has the code compiled, it's uploaded onto the device, and now it's processing the code, it will tell you how long this device has been running. So if the current time minus the last time is greater than or equal to the move interval, and remember the move interval we set up here of 300 milliseconds. So a little bit less than 1/3 of a second. And that's why you can see this thing kind of goes by kind of quick. Moves about 3 dots every second. That's because we set it up that way. So if this condition is true, what's it going to do? It's going to move the snake, check collisions, update matrix, and then set the last time equal to the current time. So let's look at these 3 functions: move snake, check collisions, and update matrix. So first one is move snake. Here it is, move snake. So the way we are doing this is, what really moves is the head of the snake, if you think about it. we are moving the head of the snake as we move the joystick. And what we want is we want these arrays, which is holding the X and the Y values. Where is it? Up here. Holding the X and the Y values of the snake's body. I showed you why we need to use the array, because it can make L shapes. So we need to keep track of exactly how we move the head and then have the body follow that part of the snake. So basically what we want to do is we want to make sure that the head of the snake is the beginning of the array, because basically what these numbers are is locations on the matrix, right? So we have a switch case which is talking about the current direction, which comes from the update direction, which is literally right here, the current direction, which is which way is the snake moving. And the way we do this is if up is the current direction, what do we want to do? We want the head's Y to be subtracted because it's upside down, alright? If it's down, we want to add one. If it's left, we want to subtract one. If it's right, we want to add one. Then what we want to do is update the snake's body. So what is this doing? It's looping through the length of the snake. It's going until we are at the last bit of the snake, right? We're starting with the length of the snake. So we're starting with the big number, we're going down to nothing. And what are we doing? We're making sure that the snake's head, well, really we're going from tail to head, is equal to the last one because we want it to follow as it moves. And then the last thing we do before we get out of this function is we're setting the beginning of both of these arrays to the new head X. So the exact opposite of what we did at the beginning. The next thing we do is we check for collisions. So how do we do that? So basically the way we're doing this is we're checking to see if it hits the walls, right? Or itself. If the snake's 0 is less than 0, or the snake's 0 is greater than the matrix width, right? If it's at the boundaries, the X boundaries, or it's at the Y boundaries, 0 and max height, 0 to 8, or really 7. Then we're going to say game over, true, and we're going to just get out. Boom. So if the snake runs into food, what are we going to do? We want to increase the length of the snake. So the way we check to see if it's actually run into the food is we make sure that the head, or the first item in the X and Y array, which is the head, hits the X and Y of the food. So if that happens, we increase the length by 1, and then if the snake length is greater than or equal to max snake length, we can do something. I just haven't put anything in because I have not been able to get up that far. But this is where you would say, you know, you win. Good job. Otherwise, if this is not the case, boom, place more food. So the only time this place food is called is if we happen to collide with the food and we're not more than the max length, basically. On place food, what does it do? We already saw that. So if we do call this function, what does it do? It randomly places the food in the matrix based on, you know, the matrix width and height. So just somewhere in the array, it will go ahead and set up the food. And then the last thing that we are doing in our loop while we're running the game is we're going to update the matrix, right? So what are we doing when we update the matrix? So we're going to clear the display. We're going to display the snake, right? And this gets called every third of a second. So every third of a second, we're calling update matrix, right? Where is it? Right here. So remember the move interval, which is 300 milliseconds. So every approximately 1/3 of a second, we need to update the screen. This is like your refresh rate, basically. Ours sucks. That's okay though. This is just for an example. So what do? We clear the display. We update the location of the snake based on its direction, which isn't even referenced in here, but you know, we're just checking where is the snake, and then we're going to display the food. So if, and all of this gets run as long as game over is not true, right? If game over is true, which means, where is it? Boom. Right here, we collided with the wall or itself, we set game over to true, and we return out, and then we come back into the loop, boom, gets to the bottom of the loop, comes back up, this is not true, because game over is in fact true, it's not false, therefore it comes down and executes the else block. So this right here is where we're going to display the game over. So what do? Boom, we cleared the display. Like I said, we're displaying all the right bars lit up, as you can see. Boom. And then we're delaying for a second, and then we're calling reset game. And reset game, this is the last thing we need to do. We just reset the game variable. So the snake length equals 1, current direction equals right, game over equals false, and if you guys can tell, this is literally exactly what we have in our setup. And up here. So game over equals false, snake length equals 1. What else? We had the snake's head being set and the food being set. So it's literally the same exact thing. Pretty simple, right? And if you wanted to change the snake's length when you start the game, all you'd have to do is change snake length right here and back up here at the top. So pretty simple explanation. I hope you guys made it this far. If you guys want the code, I will be posting it on my GitHub so that you guys can download it, upload it for yourself. All you need to do is just make sure that you set up the wiring exactly how I showed you in this video. Pretty simple little setup for a pretty cool little game. So that's all I have for you guys today. If you guys made it this far, you guys are awesome. Make sure you smash the like button, drop a comment down below. Subscribe for more interesting tutorials in our next video. I'm very excited because we are going to be talking about the gyroscope. Finally. They don't call it a gyroscope, they call it the inertia measurement unit. But this essentially is what we need if we want to make drones, planes, stuff like that, get a sense of direction. If we want to build, what's it called, a gimbal, we can build that using this device and servos. So we're really starting to ramp up the tutorials. I'm pretty excited because I really bought this whole device because I wanted to make a drone. And then after I build the drone, we're going to be building a self-landing rocket. So just get ready. That's where we're taking this channel. If you don't like it, get out of here. But you guys have a beautiful day, beautiful night, wherever you guys are. Dylan is out.